2.1. Here are your objectives for 2.1. Find the domain and range of a relation. Determine whether a relation is a function. Determine whether an equation represents a function. Evaluate a function. Graph functions by plotting points. I know that's going to be a tough one for us. Use a vertical line test to identify functions. Obtain information about a function from its graph. Identify a domain and range of a function from its graph, and identify intercepts from a function's graph. Okay? Any of that new stuff for you? No, we know how to do all that stuff. Okay, so this is, again, basically just going to be a review, but let's go through it. Okay, so this set of points right here that I'm going to give you, 2, 4, 7, 5, 3, 6, 1, negative 2, and negative 3, 0. Is this a relation? Yes, because I told you here's the set of points and they're together, right? Is this relation a function? How do you know that this relation is a function? None of what repeats? Because there's a difference. None of the x's repeat. Okay? Because none of the x's repeat, it is a function. All right? Can you determine the domain of this? We know now is a function. But if it was just a relation, if that's all we had thought about so far, can you determine the domain of this relation? Okay, so how would you go about doing that? Domain is what? X values. So what x values are here? Two, 3, 7. Why didn't I just write negative 3, 1, 3, 7, and 2? Yeah, we like to write them in descending order, right? Ascending order from least to greatest. Okay? Same thing with range. What's the range of this relation? Zero, 4, 5, 6. Okay? Now we did say it was a function, and I want to make sure you have that definition written down for you. Okay? For every x, there is only one y. Okay? So just as a reminder, we look to see if any x's repeat. If they do, if any x's repeat, yes, then it is not a function. So if I say to you, do any x's repeat, and your answer is yes, then it's not a function. If I say to you, do any x's repeat, and you say no, then it is a function. Does that make sense? Okay. What about, though, relations that don't look like this? Can we still find domain? Can we still talk about range? Can we still talk things like that? For example, can we really talk about a domain of this function? Kinda, right? Kinda. It's not numbers. It's not a list of numbers, certainly like this, right? But we know that those are names. Our domain was going to be names. Maybe teachers' names, maybe like the awesomest teacher on campus names, something like that, right? We could be more specific. Okay? What about a range? Could we talk about a range here? Yeah, we could list a range like we did up here, okay, because of the fact that those are numbers, all right? But there is a way to organize stuff like this without exactly listing it exactly like this. You can still kind of talk about x values and still talk about y values, okay? That will probably show up, okay? So what about What about evaluating a function? Let's look at the objectives again. Find the domain and range. We did that, right? Here. Determine whether it's a relation, or sorry, determine whether relation is a function. We decided we look for any repeating x's to know if it's a relation, just a relation, or if it's also a function. And then determine whether an equation represents a function or not. Can I take these points and figure out an equation that relates them all? Maybe and maybe not, right? It depends by looking at these graphs. If I graph them out and they are linear, then yes, we can absolutely find the equation of a line, right? If I graph them out and they look like a parabola, I could probably find the equation of a parabola, okay? But if it's just a scattering of points, can you determine whether an equation would represent the function or not? You can't, right? Or, and in fact, the answer is probably it doesn't. There's not an equation that represents that function, okay? However, what if I said to you 2x plus 5y equals 12, and I said what equation represents these values? Well, isn't that an equation already? Yes, but typically we write our equations y equals, right? So can you get this equation of y equals? Okay, when we were in Algebra 2, we called these literal equations. In Algebra 1, right? We called these literal equations. Yes, it's in standard form, and we wanted to get it in slope-intercept form, right? More specific words there. But if we're trying to find an equation that relates them, this is an equation that relates them, right? These two values, x and y. But what if they said to you, give me the y equals equation? Well, I say literal equations because we're taking one equation, we're solving for one specific variable. So that we would know that y equals negative 2/5 x plus 12 over 5. Yes? What if it looks something more like this? X squared plus y squared equals 16. You could still do that one, couldn't you? Subtracting x squared from both sides gives us y squared equals negative x squared plus 16. And how do I solve for y? Square root both sides. If I put the square root in the problem, what else do I have to put? Plus or minus. Okay? So does that make sense? Can you take an equation and solve it for y so that you could graph it or do whatever you needed to? Okay? So that takes care of the first three objectives here on our list. Okay, let's talk about evaluating a function next. Okay, if I'm evaluating a function, you're going to be given something that looks like this. F of x equals x squared plus 5. Okay, and then what they're going to say is find f of 2. Well, what used to be here? X. So what do they want you to put there instead? A 2. 2 squared plus 5. 2 squared is 4 plus 5 is 9. Done. We did those a lot, didn't we? Okay, but what happens if we start with this original f of x just like we had before? So I'll go ahead and write it again so we have it. F of x equals x squared plus 5. What if I want you to find f of x plus 3? Same thing though, right? What used to be here? An x. What's there now? So anywhere there's an x plus 3, or excuse me, anywhere there's an x, we want to put an x plus 3. And we could simplify this, couldn't we? X plus 3 squared is x plus 3 times x plus 3. Distribute x squared, distribute 3x, 3x, and 9. So this part of it would be x squared plus 6x plus 9. And then plus 5. So when I combine like terms, I actually get x squared plus 6x plus 14. Okay? Could you do the same type of problem if I said to you, same f of x to begin with, x squared plus 5? I said, what happens if it's f of negative x? Could you do that? So negative x goes here. Could I simplify that? What is negative x squared? Just x squared? X squared plus 5. So if I substituted a negative x for x and I got exactly the same thing, is that a thing? It's kind of an important thing, but we're not ready for that yet. So that is some foreshadowing. We're just practicing evaluating functions right now, but this is something we'll refer back to in a little bit. And by a little bit, I mean not today. Okay? But that's definitely something that we're going to be talking about. Okay? How are you feeling about evaluating functions? How many examples do I need you to give you of graphing functions by plotting points? 0. Okay. What about using the vertical line test to identify functions? None, because what do? You plot the points and then you run your pencil or like your brain, right? You can just look. Are any of the lines, or any of the points touching your vertical line more than one at a time? If there is, it's not a function, right? Okay. What about obtaining information about a function from its graph? Like what information? That's a good question. Typically domain and range, because that's even what's asked next, right? If I give you a graph, can you look and tell me its domain and range? If I give you the equation of a line or actual graph of a line, can you tell me the domain and range? Yeah, you just look, right? How far left does it go? How far right does it go for domain? How far down does it go? How far up does it go for range? That's all stuff that we spend a lot of time on Algebra 2, and I'll be more than happy to show you some examples if you would like me to. But if you'd like me to just go on, I will also do that. Okay? So a lot of the information that you're going to need is domain and range and things like intercepts. If it's a line, can you identify the slope from the graph? Yeah, you count, right? Literally count what's the rise, what's the run, things like that. So that really covers all of our objectives for the day without even giving you any examples of the last 5 objectives, just because you seem quite confident in those. Yes? And if you do have questions, yeah, ask for sure. You good?